Right, the next part's about friction. If you rub your hands together, they get warm. This is because there is resistance to the rubbing motion. So you can see this person here rubbing their hands together. Now you know on a cold day that to try and get a little bit of heat into your hands, if your hands are really cold, you'll rub them together. And you can hear a noise, but you can also feel them getting a little bit warmer. And this is because friction causes a lot of heat. So the definition of friction. Friction is a force. Now there might be 2 marks for this in an exam. So the first mark would be you would get for saying it is a force. And what does that force do? Excuse me. It opposes motion. So it tries to slow things down. And there's where you would get your 2 marks. And that's a very standard definition. And that's a definition which examiners look for all the time. What causes this force? Well, this force is caused by, it's really caused by uneven surfaces. And those uneven surfaces rub over each other. Now, even as I'm writing here on the piece of paper, this paper is photocopy paper. It looks lovely, or printer paper. It looks lovely and smooth. But if you had a microscope, you would see lots and lots of tiny fibres on the surface of that paper, and that causes friction. On the surface of our hands, we have, of course, got lots of different lines on your hands, your fingerprints, as you know, and your skin's very bumpy. And when you rub your hands together, then that's causing a lot of friction. Which type of energy does friction always produce? And the answer to that is, of course, it produces heat. Is friction useful or is it a hindrance? It depends on the situation and what you wanted to do. It says write down 3 instances where friction is useful and 3 where it is a hindrance. So when do you want friction to be useful? Well, you want to be able to walk. So you need friction between your feet and the ground. You want to be able to drive a car. So the tyres of a car on the road. And we know the problems whenever there's very little friction. Then in icy conditions, your car can skid on the road. So between the tyres of the car and the road. And you might also want friction. There's loads and loads of examples. But say you want friction possibly if you were a gymnast where they're swinging on high bars, they will rub their hands in some kind of powder before they actually grip onto the bars. So gymnasts use it. Now, if you were asked for an answer, don't just write down gymnasts. Write down gymnasts use powder on hands to create friction when they're swinging the bars. Give it a full answer. Where is friction a hindrance? Friction is a hindrance if you want to move faster. And so if you're running a race, and you've seen runners wear lycra sportswear, they shave their body hair. Swimming as well is the same, where swimmers either wear those full body suits or they shave their body hair. Cycling, and you know what they do, they will wear the lycra body suits. They will wear a helmet which is kind of that shape, and that streamlines friction due to air or air resistance. So don't just write one answer, make sure that you explain what you mean. So what does friction do to the speed of a moving object? Friction occurs when things move through air. This is called air resistance. Or it's often called drag. Now this is a picture I got from the internet, and it shows a cyclist, and obviously this has been taken in a wind tunnel, and then in a wind tunnel where they put artificial smoke in, and they can map the flow of air over the body, and you can see there the amount of disturbance the person's creating as they move through the air. And so if they can streamline that so that the lines are lovely and straight behind them, then they're going to be able to move quicker. And so that's what air resistance is. Don't ever write wind resistance. There's always air, even on days when it's not windy. They will mark wind resistance wrong. Right, the direction of friction. We've already said that friction is a force which opposes motion, so it always acts in the opposite direction to that of which the object is moving. So you have to know what direction the object is moving in, first of all, before you would show what direction friction is acting in. So we've got arrows here showing the direction of motion of the object. For the following moving objects, mark with an arrow the direction that friction is acting in. So this object is moving to the right, so friction must act to the left. This object is moving down, friction must act upwards. This object is moving up, so friction must act downwards. I'm realising you can't see that. I'll just show you there. So the object's moving up, so friction must be acting down, and this object is moving to the left, so friction is acting right. Okay, sources of friction. This is just one example, and this is an example of a bicycle. And I'll push it up a wee bit so you can see the whole thing. And you can see all the places there where friction acts. Now, some of those are obviously for a reason. In fact, most of these are obviously for a reason. And then sometimes you get friction where you don't really want it. So I'll just show you a few places. You have friction between the brake pad and the rim when you want to stop the bike. You can't see the brake pad there, but the two wee blocks at the front of your bike, which squeeze the rim of the bike whenever you pull the brakes. So you want friction there. A wheel bearing, there's friction in here at the wheel bearing. It might sometimes, if there was rust or something, you might have to oil this to stop it squeaking. And there's friction there, which you probably don't really want. You want the wheel to move around quite smoothly. You've got links in the chain. You will want friction there because you want those links of the chain to hook into the gears here or to the cogs to make sure that the cogs are pulling the chain around and helping the bicycle to move. Friction between the tyre and the road. You do want friction here. Now the funny thing here is, and I'm just going to put this in, if you want your bicycle to be able to move, it has to be able to move forwards. The wheel has to move forwards. So the wheel will be moving around in that direction as it's moving forwards. But remember, friction opposes motion, and so the friction between the tyre and the road actually acts in that direction, very oddly, when the bicycle is moving. And it's obviously the same with a car, so I don't know if you can see that. I'll make it a wee bit bigger. There's the direction that the friction is acting between the tyre and the road, and this is because your wheel is moving around that way as the bicycle is moving forwards. There's wheel bearing again, and the pedal bearing down here again. You want your to be able to move the cog around here as you push it. So you have to have a bearing there, but there's going to be friction there as well. Now the last one is the biggest one here that you can see, and this friction is caused by air resistance or drag. It's most important because it slows the bicycle down. So someone on a bicycle is only about 15% efficient, which means that 15% of the food that they eat is converted to kinetic energy as you ride the bike. So an awful lot of that energy is lost due to heat, and that's because of air resistance or drag. And it acts in the opposite direction to the direction you're trying to move the bicycle, which presumably is forward.